Hello everybody and welcome back to Algebra 2. Today we're going to be talking a little bit more about linear equations with 2-4. Let's begin. First we're going to start off with the vocabulary like always. We must write each sentence as an equation. The sum of x and y is 8. Well, that's the same thing as talking about some form of addition because sum represents addition. So we have x plus y, and whenever you see the word is in some sort of sentence like this, is actually going to represent our equal to portion. So x plus y equals 8 should be the answer, and that's what we get. The product of p and q is 7. Again, product represents multiplication, so multiplying p and q, the answer is going to be 7, which means it's going to equal 7, so we have p times q equals 7. And then you have the square root of y cubed is 2. So for this one, we have to take the square root symbol, which is the square root of the y value, and cubing something means that we are going to actually raise it to the third power, and that entire thing must equal that 2. So you'll get something that looks very similar to this. But notice everything is inside the parentheses once again. Great work! Let's start talking about what intercept means. So we have related words such as the x-intercept and the y-intercept. An intercept of a line is a point where the line crosses an axis. And that's why you have the x-intercept and the y-intercept, because it's going to be crossing the x-axis or the y-axis. You can kind of think about this like as in football. If a person were to intercept the ball, it's because they got in the way of the ball getting to the wide receiver, and they were able to intercept that ball because they were there to intercept the path that the ball was going. So we're going to use the graph on the right to write T for true or F for false. So the very first thing I'm going to look at is the x-intercept of the line is 0. Well, remember, we have to pay attention to the different coordinates that we have. Remember, x always comes first, then you have the y values. Well, if we're talking about the x-intercept, that means that we have to have a specific number in for that x value. So for this one, we have x is going to be 4. And as you can see, it looks like it's crossing the x-axis at 4, so this one must be true. And notice that the y value is going to be 0 because it's not above or below that x-axis. What about the x-intercept of the line is 0, 4? Well, if we just said that the x-intercept was 4, 0, which means this one must be false. So let's take a look at the y-intercept of the line. It looks like it's going to be crossing the y-axis at -1. But that is the y equals to -1. So y has to equal -1. Well, for this problem right here, the coordinate starts with the x being the -1, so we know that this must be false, and then the true must come afterwards with the y-intercept being 0, -1. So again, the y-intercept has x equal to 0. The x-intercept has y equal to 0, and that's going to be very important for later on. Well, let's talk about the concept summary. All right, we have learned a little bit about the slope-intercept form. You might have seen the point-slope form, and you did see a little bit about the standard form last presentation as well. But really, the point-slope form is going to be something that's slightly different. But all of these names come from what is important about them. Like the fact that slope-intercept form, that represents something that has a slope for the m value, or b, the intercept, more importantly, that y-intercept. All right, the point slope, you can kind of assume what you need. You need a point, which is represented by the y1 and the x1, and you need the slope, which is represented by the m, just like in the previous one. And once you have a point and a slope, you can then put it into the point-slope form. The standard form, however, it's going to be its own special way, but basically the most important part is that a and b have to be real numbers, and they also cannot be zeros. They are allowed to be fractions here and there, although for the most part, I always like keeping them as a whole number. Alright, so the a and the b for me will always be a whole number. Write I if the equation is a slope-intercept form, P if it's a point-slope form, or S if it's in standard form. Well, the very first thing I'm looking for is if it says R equals or Y equals, I know that it's going to be probably slope-intercept form, because as you can see, the only one that has a variable equal to something is going to be that. So looking at this first problem, we have r equals 5s plus 7. It looks like we do have our m right there and our b right there. So I would say that this is going to be, in fact, slope-intercept form. 8m plus 6n equals 2. Well, it looks like we have two different variables on the left-hand side, and both the point slope and the standard form do allow having variables, but like I said before, the y1 and the x1 are from points. So these will actually be numbers. So the one that I'm going to look for would be the standard form, which means I'm going to put an S right there. Now it looks like we do have the variable on either side, which is good, and it also looks like we have a number in, so we're talking about some sort of point attached to the variables as well, so I'm going to lean towards this being the point slope form. And last but not least, you have a variable by itself being equal to another variable plus a number. That screams slope-intercept form right off the get-go. Great work. Problem 1. Writing the equation given a point and the slope. What is the equation of the line through the point negative 7, 1 with the slope of negative 3? Well, if we are given a point and we are given the slope, we know that we must use the point slope form. So let's figure it out. If we have our point, we do have our x1 and y1. The x1 is going to be the negative 7. The y1 will be that 1. So I'm going to just plug in the y1 next to the y value because that's what it says. So the y1 was 1, so it's going to be y minus 1. We do know our slope. Our slope happens to be a negative 3, so I'm going to plug in negative 3 in right there. And last but not least, you're going to plug in the x1, which happens to be a negative 7. So the first thing I'm going to do to simplify this down so we can rewrite the equation is I'm going to just get rid of the parentheses on the left-hand side because y minus 1 doesn't need the parentheses. And then I'm going to, more importantly, pay attention to what's inside the parentheses over here with the fact that I have an x minus a negative 7. And if you have a minus and negative, I'm going to change those to positives. So it's going to be x plus 7. So our new equation should be y minus 1 equals a negative 3 parenthesis x plus 7, close that parenthesis. Problem number 2. Writing an equation given 2 points. A line passes through the point negative 5, 0, and 0, 7. What is the equation of the line in point slope form? Now, point slope means that we are going to be using one of these points, but we also need to figure out what the slope of the line is. So in order for us to figure that portion out, we actually have to plug it into the slope formula, which is going to be m is equal to that y2 minus y1 all over x2 minus x1. So if we had to plug this in, I'm just going to make the y2 is going to be my 7, which means the x2 is going to be 0. And then again, I'm going to do the y1 will be that 0, and then the x1 will be that negative 5. So that is going to be the same thing as a 7 minus our 0 all over our 0 minus a negative 5. So we should have 7 minus 0, which is 7 on top, and then 0 minus a negative creates a positive, so we should have a positive 5 on the bottom, meaning that our slope for this equation right here will be 7/5, which is exactly what we have right there. Now let's write the equation in point slope form. Remember, point slope form is going to be that y minus y1 has to equal m times x minus x1, where again, y1 and x1 are any of these points. You do not need to use the original y1 and x1. It could very well be the x2 and y2 that we used to plug in, if you would like. For me personally, these aren't negatives, so instead, I'm actually going to use the y2 and the x2 personally myself. So we're going to do the y minus our y2 value, which we're going to change to the y1, quote unquote, and that is going to be a positive 7. I'm not going to worry about the parentheses because of the fact that it is a positive 7. And that's going to equal our slope, which we said was 7/5. And we're going to multiply that by the x, but we're going to subtract our x2, which we call x1 down here, Alright, just because I wanted to get to subtracting that 0, to be honest with you. So we're going to have a 0 right there. And now we can simplify it down. So I know that this is going to become y minus 7 is going to equal a 7/5 times your x. If you want to, you can rewrite this without the set of parentheses. So it would be y minus 7 equals 7 over 5x. Problem number 3. Writing an equation in standard form. What is the equation of a line y equals 9.1x plus 3.6 in standard form? Well, let's talk about the error analysis. Karina made 2 errors while writing y equals 9.1x plus 3.6 in standard form without decimals. What are Karina's errors? Can you explain how to correct them? Well, if we take a look over here, it looks like when she was actually going through it, she did multiply everything by 10, which is correct. If we want to get rid of the decimals, we need to be able to move the decimal from the place that it's in all the way to out in front, which means that we would have to move it 1 time, which multiplying by 10 will do. However, as you can see, if we multiply by that 9.1 by 10, we also must multiply the 3.6 by 10. So in this case, she did not distribute the 10 over both the 9.1x and the 3.6. She also should have moved the 91x to the other side of the equal sign. So as you can see right here as well, this is not in standard form because we need to make sure that the x and the y are also on the exact same side. Remember, standard form was that ax plus the by has to equal your c. C being a constant, the a and the b representing the coefficients of the variables, and the x and the y being the variables that we're talking about. So let's write this equation actually in standard form. So if I take what she wrote, so we have the 10y equals the 10 times the 9.1x plus the 3.6. I'm going to distribute out that 10, giving you a 10y is going to equal a 91x plus a 36. And then I'm going to subtract the 91x from both sides because, again, you really need to get the x and the y on the exact same side. And then that will equal the 36 at the very end. And if we were to rewrite this out, we're going to keep that negative as the negative 91x, and we're going to put that on the outside, so negative 91x plus the 10y, which is shown right here, is going to equal the 36. Great work. Problem number 4. Graphing an equation using intercepts. Well, what are the intercepts of 2x minus 4y equals 8? Can we find each intercept? Now remember, the x-intercept is going to be represented by the x number with y equal to 0. And the y-intercept is going to be x equal to 0. And then the y value will be whatever it is. So if we write the original equation, we're going to put the original equation right here, and it's going to equal the 8. All right. We must substitute 0 in for the appropriate variable. Well, if we're trying to find the x-intercept, our 0 is going to be y. So this becomes 2x minus 4 times 0 equals 8. And if we're trying to find the y-intercept, again, we're going to change out the x variable for the 0. So you get 2 times 0 minus the 4y equals that 8. So 2x minus 4 times 0, 4 times 0 equals 0. So 2x minus 0 will just give you that 2x, and it's still going to equal 8. And then 2 times 0, once again, is 0. So 0 minus that 4y will give you a negative 4y, which again is still going to equal that 8. We then just have to simplify. For me, dividing 2 on both sides for the very first one, giving you 8 divided by 2, which means x equals 4. And then you also have the negative 4 that we're going to be dividing from by both sides, and you get 8 divided by negative 4, which is that negative 2. Now, this isn't the end of the problem because we do have to make sure we graph it. I'm just going to give you guys a little bit of time to look it over. Pause the screen right here if you like, but I'm about to move over in 3, 2, 1. All right, so question 14. Now plot the intercepts and draw the line. Well, like we showed in the previous one, we know that the first intercept is going to be based off of the x-intercept, which is the x and the 0. So the x-intercept for this one will be 4, 0. The y-intercept is going to be based off of what you just previously saw, which was the y equaling -2. So our y-intercept is going to be the point 0, -2. So if I had to graph the x-intercept, I'm going to go all the way over to the 4, and I'm going to not go up or down because the y value is 0, and I'm going to put my point. For the y-intercept, I'm going to do the exact same thing, only instead of, I don't have to go left or right first. So instead of doing that, I'm just going to go down to that 2. I'm going to put my point right there. And then you can draw your line that goes straight across everything. It doesn't have to be picture perfect. It can be as close as you can, 100%. And let's take a look and see how close I got. It's pretty close. Good enough. All right, but that is how you'll do. But that is how you'll graph each of these equations if you were looking for the intercepts. Problem number 5. Drawing and interpreting a linear graph. The office manager of a small office ordered 140 packs of printer paper. Based on average daily use, she knows that the paper will last about 80 days or so. What graph represents this situation? Well, complete the table of values. For the 0 day, which means we haven't even started everything yet, we couldn't have used printer paper. Why? It's because we haven't had a chance to. Alright, however, if we're talking about after 80 days, clearly she understands that after 80 days, we're going to be going through 140 packs of printer because that's how many she ordered, and she's doing it based off of the average daily use. So I know that 80 will be right here, and for every 80 days, about 140 will be used. Normally, the tables are represented based off of the X and the Y right off the get-go. So the X values are going to be represented by days, whereas the Y values are going to be the packs of printer paper used. So if I were to write the Y title, which would be packs of printer paper used, I'm going to write that down the left-hand side that you see, and on the bottom will be the X title, which is going to be represented with days, or number of days. So how can we graph this situation out? Well, on 0, we're going to be at 0, 0. After 80 days, it's going to be all the way up to 140. So as we can see, this is probably jumping 40 each and every time, which means this is going to be around 120, which means about halfway up, it should be around the 140 mark. And then we can draw our line straight through that point, always making sure that we have our arrows at the end. All right, and let's see how close we got this time. That's pretty spot on. Great work, guys. Problem 6. Writing equations of parallel and perpendicular lines. Well, what is the equation in slope-intercept form of the line that passes through the point -4, 2 and is parallel to 4x plus 2y, which equals 7? Well, first things first, we need to figure out the slope of the line for that 4x plus 2y. So if we had to find the slope, that means that we have to figure out what is next to that x value after we solve for the y value. So for me personally, I'm going to go about solving this one out normally. So we have our 4x plus our 2y is going to equal 7. I'm going to subtract the 4x from both sides, and that will give you a 2y is going to equal a -4x plus 7. Again, positive 7 stays positive with the plus sign. The -4 is because we're subtracting over that 4. And we're going to divide everything by 2. So I'm going to divide this first part by 2 as well as the second portion by 2. So I know that y is going to equal a -2x plus a 7 over 2. Now that -2x we know is going to be the slope because of the fact that this represents our mx, or our slope times the x. So our slope for this one will be -2. Now that we know the slope, we can then figure out everything based off of what we know. So circle the form you will use to write the equation. Since we have our point and we have our slope, I'm going to probably plug this into the point-slope form. Why? It's because we have it all. We don't have the y-intercept, so I don't want to use this. And in standard form, it does give us it in standard form, but we just rewrote it as a completely different form altogether to get that slope. So I'm not going to use standard form either. So let's write and simplify the equation. Let's start off with the y minus y1, which was 2, because I'm getting that from the point that is given. And that's going to equal our slope, which happens to be a negative 2, times our x value, again, minus a negative 4, because we're taking the entire number that is the x value from the point given, which means that we then have to recreate by putting plus plus. So we get y minus 2 is going to equal a negative 2 times an x plus 4. So we do need to simplify this down even further. So I'm just going to multiply everything by that negative 2. So that will give you a y minus 2 is going to equal a negative 2x. And we're going to subtract the 8 because negative 2 times 4 gives you that negative 8. I will then add 2 to both sides, and I promise I'll be moving this up as well. Bring it right here. So now we are looking at y is going to equal a negative 2x minus 6, because negative 8 plus 2 will give you that negative 6. And this is written in slope-intercept form, and this line will be parallel to 4x plus 2y. And the reason I know it's parallel is because in order for a line to be parallel, it needs to be going in the same direction to a t, which means that the slope of a parallel line needs to be the same. Now, what they don't say is that for perpendicular lines, you have to have its negative reciprocal, which means that it has to create a 90-degree angle. All right, I know that the slope for the very first line was a 2. I then have to do the slope of the perpendicular is going to be its negative reciprocal, or slope of the perpendicular line, which is where I'll just draw that nice little picture. It has to equal its negative reciprocal. So the negative portion, positive, goes to negative, and the reciprocal means that instead of it being 2 over 1, which is the whole number, it now gets flipped and turns into 1 over 2. So the slope of the perpendicular line given would actually end up being a negative 1/2. Now for this problem right here, we see that their slope was negative 2, so actually it would be, instead of it being a negative, our slope of our perpendicular would then turn into a positive 1/2, because we're changing the sign from a negative to a positive. And we finally made it to the lesson check. We're almost done, guys. Let's keep on powering through. If the intercepts of a line are a0 and 0b, what is the slope of the line? Use the points to calculate the slope. Well, again, we have to pay attention to what we have, right? So we have y2 minus y1. It looks like they're saying b is equal to the y2, which means our y1 must be 0, which is perfectly fine. But that also means our x2 is going to be that 0, which they also have down here, and our x1 will be the a, and we'll be talking about that later. So b minus 0 will equal your b. And then again, our x1 will end up going all the way down into here. So we have 0 minus a, which is going to equal a negative a. So the slope of the line that passes through the points a0 and 0b will be b over negative a, also known as negative b over a. And that is it, everybody. Great job, great work today. Congratulations. Remember, have a great day, stay out of trouble, don't do anything stupid, and I'll see you guys in the next one.